I'm Dan Edmonds, and this is the new 250 series Lexus GX550. If you think you're seeing double, well, you're not wrong, because I recently had the new Land Cruiser in here, and they're both built on the same 250 series Land Cruiser Prado chassis. Now, there are differences. For example, this one has a completely different engine, and that has some knock-on effects, but exactly what those differences are, well, we'll see that when I pull the wheel off and have a look at the suspension. And then later, I'm going to drive it up my RTI ramp to see if its suspension flexes any better or worse than the Land Cruiser. Well, here we are looking at the front suspension of the new Lexus GX550. And I gotta say, a lot of it looks the same as the Land Cruiser, as you would expect, because they're both based on a 250 series chassis. But there is a huge difference, and that has to do with the stabilizer bar. This has E-KDSS, and that system's mounted in front of the axle center line. The Land Cruiser has a simple disconnecting stabilizer bar, and it's mounted behind the axle center line. So big differences there, but similarities are the basic layout and even the width of the suspension out to the face where the wheel bolts on. All of this is virtually identical. We have a mid-mount ball joint that's actually kind of behind the tire, so oversized tires will fit. We saw that on the Land Cruiser. We are seeing it here. We're also seeing a similar amount of anti-dive in this angle downward slope of the upper control arm. And of course, same upper spring mount, coilover, but this coilover is an adaptive Tokiko, not a passive one. You can see the little wire coming out of here that goes down and does the adjustments. So just like the Land Cruiser, we're seeing a lower control arm that's comprised of three pieces. It's a weldment of two folded pieces that are welded along the seam, and then a forged piece out here that's welded to that combination that gives the lower end of the coilover someplace to bolt to. And then of course we're seeing the same construction here, with the knuckle having a separate piece here with the little stops for steering. All this is identical. What's different is this bracket that's been welded on to this lower control arm that allows the stabilizer bar to pick up here rather than on the other side. And so it's good because we can see the motion ratio of everything in one go. I mean, we're looking at the same, I don't know, ball joint here, connection point here, inner pivot there. 70% motion ratio, maybe a little more for the coilover, and then the stabilizer bar, kind of like the Land Cruiser, which was on the other side, but about just as far out, looks at about 55%, something like that. The big difference between the GX and the Land Cruiser is right here, E-KDSS. Now, E-KDSS, at least from this angle, looks similar to KDSS on my old 4Runner, but it's completely different. Now, what it's got is a cylinder here that can be allowed to go limp, so the stabilizer bar becomes ineffective, but it doesn't just have one on this side. It's also got one way over there on the other side of the vehicle. So while this one's compressing, the other one's extending, and vice versa. So this thing really can wobble in here. Now, to prevent it from moving around too much while both of these struts are loose, there's actually a third pivot in the middle. I'll try to get a better shot of it. So it's a little bit of a teeter-totter. So there's a bracket in the middle that supports the middle of the stabilizer bar and keeps it in the right spot while the two ends go crazy and release. Now, that's not done the way it was before. Now there are sensors, there's a computer, these things are linked together hydraulically, and a valve opens so they can flop around, and then the valve closes to hold them back in position again. But all that is sensed by sensors rather than the old system, which was totally passive. This shows everything. In the blurry foreground, you see the strut on this side. In the background, you see a little bit of the bellows of the strut on the other side. And right in the middle is the fixed bushing that acts like the center point of a teeter-totter. So there's lots of electronics, but man, I'm looking at a center stabilizer bar bushing that is right under the skid plate that I sure wouldn't want to knock out of position on a rock. I'm not so sure about this. Maybe the Land Cruiser's protected position behind the axle is a better idea for really rocky off-roading, but we're going to have to see how that pans out. It may be more protected than I can tell from here. All right, this view shows everything just a little bit better because I've turned the wheel here. Interestingly enough, just like the Land Cruiser, we have a physical exterior bump stop that registers on the actual lower control arm. And this Tokiko shock is a twin tube. We can see that because of this wasted design down here. But it does have variable damping. And it's electronically variable on the overtrail. The Land Cruiser has passive shocks, which frankly, I kind of like. Because if I was going to replace these, this thing might return some kind of dashboard warning because of the electronics being interrupted. Whereas the Land Cruiser wouldn't because the shocks are just passive ones anyway. While I was down here, I figured I'd talk to you about the tow hooks. Now, here they are. You can see the other one over there. I think the other one on the other side makes my point better. So this is what I'm talking about with regard to the recovery point. I mean, this is the tie-down hook that is used for shipping, but the recovery point is right here. And you can see that, this bodywork's kind of in the way if your winch cable is going to go up. If it's going down, fine, but you can't control that. So this bodywork just seems to be in the way. And then, of course, the KDSS strut is here. That's fine. This fine. But there's a teeter-totter bushing in the middle that has to stay in place. Yeah, if you hit a big rock right here, I don't know. Are you going to have problems? Not sure. I think I like the Land Cruiser's approach where the stabilizer bar is back there a lot better. So the GX's brakes are very similar to the Land Cruiser's. It's still a 4-piston fixed caliper. Now it's weird. If you read Toyota documents, you might see them called twin piston opposed. And what that means is there's 2 pistons on this side opposing 2 pistons on that side. I find that nomenclature a little bit weird, so I'm going to call it a 4-piston fixed caliper. You can see the little wire here that releases these pins so you can pull pads out. All that's the same. What's different is this rotor is just a little bit bigger in diameter. And the reason for that is because the 3.4 liter twin turbo V6 puts out continuous horsepower and torque that allows a 9,000 pound tow rating, whereas the Land Cruiser's hybrid system is fleeting. It gives you nice bursts of it when you need it, but it won't pull a trailer up a long grade to the same extent. So that's why the Land Cruiser is rated at 6,000 pounds. And for that reason, it doesn't need the same size brake rotors. This twin turbo V6 can do 9,000 pounds. And so it needs bigger diffs and bigger brakes. Whereas the Land Cruiser's Turbo 4 hybrid can tow 6,000 pounds. So they can install lighter components, save a little money, and still have the same relative durability related to its tow rating of 6,000 pounds. So this area back here looks different on the GX, and that's probably because it's got this V6 twin turbo engine and a 10-speed automatic, a bigger, bulkier setup that requires different mounting points probably. Anyway, this gap here above the skid plate is approximately where the Land Cruiser's stabilizer bar and its disconnect mechanism live. But of course, it doesn't have this big oil pan, which is part of the transmission. So this is a little different because of the engine difference. Well, that's it for this look at the front suspension of the GX550. And I have to say, I'm a little bit torn. I mean, a lot of it looks great because it's frankly similar to the Land Cruiser. But the location of E-KDSS seems a little bit vulnerable. I'm kind of liking the Land Cruiser's rear-mounted stabilizer bar with a simple disconnect from that standpoint. Also, I can kind of see how this might be why the approach angle of the GX isn't quite as good as that of the Land Cruiser. Anyway, I'm going to put the tire on, we'll go to the back, we'll see what's up back there, and then, of course, the ramp. So here we are at the back of the GX550, and as suspected, it looks very much like the new Land Cruiser. Because they're both 250 series based, they both use Toyota's next generation architecture, that's TNGA-F for frame, and yeah, they're very similar. The hard points for the links that locate the solid axle, the pads for the coil springs, all of that is the same. They are tuned differently because this one is rigged to tow 9,000 pounds because of its engine and powertrain, not 6,000 pounds. So the rear suspension, you may notice it has a little bit more rake, a little higher stance in the rear. I think that's to accommodate tongue weight. But yeah, everything else is the same, except, of course, the dampers, which are adaptive, just like they are in the front, as opposed to the, the totally passive throwaways on the Land Cruiser, and the stabilizer bar, which has E-KDSS. Now, there's only one actuator on the driver's side of the vehicle, the side we're looking at. The other side is totally normal, and so that's different from the front where there's a teeter-totter arrangement. Right off the bat, it's easy to see the bump stop and the witness mark on the axle where it contacts. This is hard rubber. It is tapered a little bit so that it engages somewhat gradually. So here's the rear shock, and you can see that this valve here is where the adjustments are made on the overtrail. And there's a little guard here that protects it from trail damage. This is a little extra reinforcement that's also protecting the body of the shock from trail damage. Looks like this is a twin tube shock, which would explain why it's not inverted, because twin tube shocks need to be run right side up, so the base valve is always immersed in oil. So this is the KDSS system in the rear, and of course, even though the front and rear aren't linked hydraulically, there's still hydraulics involved, and that's how the struts are made to be locked or free. And basically, these go to a manifold that has a valve that basically allows them to be locked or free. When it's locked and the thing is rigid, no fluid can flow in these. But when it's unlocked and it goes limp, it's because the valve's been opened and the fluid can circulate through all of this. So the rear KDSS actuator works differently. There's just the one on this side, right here. And it's connected to this horizontal bar at this point. And of course, then there's this rigid piece, which is connected to the frame that connects to the horizontal bar at this point. So when this cylinder is kept rigid, these 2 points stay right where they are, which holds that point right where it is. Now, when you allow this to go limp, well, then this can move relative to this. This can move way up and down, which basically makes the stabilizer bar ineffective. So you got to imagine that this point is either held fixed in space when KDSS is solid, or allowed to move indiscriminately when it's open. And another way to picture that is this hole right here is where a regular stabilizer bar link attaches in a Land Cruiser. So you can imagine a fixed link here holding the stabilizer bar and making it work, or in this case, when this goes limp, you let this link go limp, and then the stabilizer bar doesn't work. I mean, you have to visualize it that way because it's pretty hard otherwise. But behind this point is a regular stabilizer bar. We're just seeing the top of it here. It's a one-piece unit, goes all the way to the other side, but basically this, what is supposed to be a fixed point, can either be fixed or free depending on what KDSS is doing. So there's a fundamental difference between the way old KDSS and new E-KDSS operates. The old system had front and rear actuators that were linked hydraulically. And if you were rolling and the vehicle's doing the same thing on the front and rear at the same time, like in body roll, well, then the fluid would deadhead and the cylinders would stay rigid and the stabilizer bars would work to suppress body roll. But as soon as you got into a frame twist situation, well, now the pressures are in opposite directions, and so the fluid could circulate and allow the struts to expand and contract as necessary, which basically disabled the stabilizer bars and allowed for massive articulation. Well, this does the same thing, but not the same way at all. The front and the rear are completely independent. They're separate from each other except for with software and lines of code. The front end decides when to unlock based on its read of the terrain, looking at the pressure in the cylinders on both sides, steering angle, a whole number of sensors, and then it unlocks. And then as soon as the obstacle is passed, it locks up again. And then there's like a timer that starts, and the vehicle basically computes when the rear axle is going to get to the same obstacle, and then it unlocks. And then after that's passed, it locks again. So the idea is only one end is unlocked at a time, and that reduces head toss for the occupants inside. And it really works. But it's also more complicated because there's a lot more lines of code involved. You still have all the hydraulics, but now they're not linked to each other. They're islands unto themselves that are controlled by computers. So why are we looking at a differential here? Well, it's because some 250 series haters have decided that the new Land Cruiser is inferior to the 300 series Land Cruiser sold elsewhere because it has smaller differentials. Well, I looked into it, and that's not really the case. Yes, our 250 series does have smaller differentials, but it's because of the engine, not because it's a 250 series, because the GX, this GX, is also a 250 series, and it has the bigger differentials. So what's going on? Well, it's because the tow rating here is 9,000 pounds. And when you're towing, that's when the diffs really take a beating. 250 series Land Cruiser, small diffs, 250 series GX, bigger diffs. And it's because of their engines and the tow ratings. Like the front, the rear brakes on the GX are pretty similar to those of the Land Cruiser. We've got a single piston sliding caliper like the Land Cruiser. These are Toyo Open Country AT3 tires, 265/70 R18, just like the Land Cruiser. Interestingly, though, the Overtrail has 20 millimeters more track width than the Land Cruiser, even though the suspension is the same. And I think I've figured out exactly why that is. So as you can see, these are 18 by 7.5 inch wheels. That's exactly the same as the Land Cruiser. But these have 50 millimeters of offset. The Land Cruisers are 60. So this 10 millimeter difference pushes these wheels 10 millimeters out per side, which is why this has a 20 millimeter wider track width than the Land Cruiser. It's all down to wheel offset. So what does one of these GX550 wheel and tire assemblies weigh? Well, let's find out. $66.2 pounds. That's not bad, and they did feel pretty light picking them up. Well, that's about it for this close-up look at the GX550 suspension. I'm going to put this tire and wheel back on, button everything up, and drag out my ramp and see how well this suspension articulates. All right, so we've seen the suspension of the new GX, and we've gawked at its E-KDSS system. The one thing left to do is to see how well it flexes on my RTI ramp. Now, if you notice, there's a couple of pieces of blue tape there. Those are left over from the Land Cruiser measurement I made recently. The lower one is with the bar connected, that's 549. The higher one is the bar disconnected, that's 631. So the question is, will E-KDSS outdo the old school disconnecting stabilizer bar system? I'm just going to make one pass at this because unlike the disconnecting stabilizer bar, this thing happens on its own. It just senses what's going on, unlocks the stabilizer bars, and gives me all it has. So I'm just going to make one pass. One thing I'm not crazy about when it comes to the new GX is the approach angle. it's several degrees worse than the Land Cruisers, because even though they've got rid of that weird grille that GXs have had in recent years, they're still kind of married to the concept enough that this grille hangs down a little bit more. There's a little bit more front overhang, a little bit more nose on this car. Anyway, here in front of the tire, it's a little different. The Land Cruiser has a wedge that looks like it had come off on the trail, and in fact, one did come off when I was out wheeling it. This has a little flap. Still, not a ton of clearance here, but enough to go up the ramp. All right, now it's the moment of truth. Well, I think I found the spot, but of course the sandpaper test will tell us for sure. It won't go in, but I can lift it up with just a finger and it goes in all the way if you want to see that. And you can see as it's kind of bouncing, it's taking bites on the way out. Perfect. It is just barely touching. Or not, which is what we want. Couple things to note here. I have not taken this vehicle off-road yet, but someone else has, and you can see they definitely ran into the limitation of the GX's approach angle. Scratched this up good. This is scratched too, but it looks like it unbolts. There's a wedge here in the Land Cruiser, but it's bigger and even more offensive. But the bumper's different, so yeah, take this off. This is touching right now, just barely. Don't think it matters too much because it's flexible. I don't know what it looks like from your angle, but from my angle, it looks like the GX has come up short and doesn't match the Land Cruiser's articulation performance with its stabilizer bar disconnected. Now remember, we're looking at the upper edge of this piece of blue tape, not the lower edge, so that's the edge to look at when I put this up here. Well, lucky for us, the place where this landed is going to result in a piece of tape that doesn't completely cover up the 631 of the Land Cruiser, so we'll still be able to read it even after we put this one down. (23 5/8 of an inch). All right, so 23 5/8 is 23.625. Yes, I carry all the decimals I can. So 23.625 divided by the sine of 20 degrees is 69.07 inches of climb. Divide that by 112.2 and multiply by 1,000. And we get 616. So it's close. 616 for the E-KDSS equipped GX550 versus 631 for the Land Cruiser with its stabilizer bar disconnected. I mean, that difference in ramp climb is less than the width of this piece of tape, and that equates to this difference of some 15 points, which percentage-wise isn't much. But at the same time, the simple solution that the Land Cruiser has works just a little bit better. Well, I'd call that a result. We're talking about a Land Cruiser with a simple front stabilizer bar disconnect versus a GX with a sophisticated E-KDSS system that works on the front and rear stabilizer bars. And the difference comes down to 15 points. The Land Cruiser pips the GX 631 to 616. That's barely 2.5 points difference. It's really not a reason to buy one or not buy the other, at least the number. Now, you could argue that with the simple stabilizer bar disconnect, there's less to go wrong out in the wilds, and so you might feel more comfortable with that. On the other hand, speaking of comfort, the E-KDSS system does release the front and then the rear bar in turn, So if you're on a dirt road and you go through cross-grain ditches, this might have a little less head toss than the Land Cruiser. But a little, I think, is the watchword in all cases here. Frankly, for me, the reason I'm not as enamored with the GX has more to do with these things and how they screw up the breakover angle, the approach angle not being exactly as good as I'd like it to be. They both have 33-inch tires. These are probably better Toyo open countries than the Michelin LTX trails on the Land Cruiser. So, but if you were going to change your tires anyway, that wouldn't matter. They're 33 inches. There's plenty of room for them. You can see them stuffed up in the fender. No problem there. Either one of these is a good truck for off-road exploration, but I think this one is just a little bit more street focused and towing focused, as its engine supports 9,000 pounds of towing instead of the Land Cruiser's 6,000. Anyway, that was a lot, but what we ought to do is put these scores on the board and see how they compare to everything else. So here's some scores I've measured recently. 200 series Land Cruiser, the Heritage Edition, the one that's gone, 661. The new 250 series Land Cruiser with the disconnectable stabilizer bar, disconnected, 631. An LX 600, which is a 300 series Land Cruiser sold by Lexus, 630. So, I mean, this is kind of an interesting comparison between 250 and 300. Now, this is my forerunner with normal old KDSS, not E-KDSS, 563. And you can see that this one's going to slot in right in here in between. So, better than old KDSS, although these platforms are different. But importantly, this is the same platform, well, this too, really. And this is 15 points less than this. Not much in it, but a little bit less. Not a reason not to buy it, but certainly this doesn't require you to push a button, and this does. This has a lot of electronic controls. This doesn't. But anyway, yeah, I mean, I'm still on Team Land Cruiser here because, well, I'm an RTI snob. Otherwise, I wouldn't be doing this. Anyway, that's what I think. Let me know what you think in the comments. And as ever, this is Dan Edmonds saying, thanks for watching.